Okay, so this video is basically going to cover a few things. It's going to cover very quickly just a quick introduction over what these videos will do and hopefully will help you. So first of all, I know that the time has been extended to April 24th. So although we do have more time off, I am not extending the amount of work on Edmentum because I've had a lot of people complain that some of it is hard. It's hard to understand. I've had to unlock mastery tests. Some students still haven't even started because yes, I can log in and check to see who has started and who hasn't. So for that reason, I'm going to leave the same amount of work, but I will probably after about 2 weeks start going over some of the review questions that I also left from the packet. But I do want to concentrate on these first. I do plan on doing about one every 2 or 3 days. It's a lot because I have to do 2 separate ones, one from Algebra 2, one for Geometry, and I just got done with the Algebra 2 one. It was a quite bit of a long video. It'll be longer than this one because this one is only 3 pages. Theirs was, I think, 5 pages of notes. But it was under an hour, the video, and it's taking forever to upload. So I will try to keep this one a little bit shorter, go a little bit faster, talk a little bit faster. You can always pause the video if you need to. But for that reason, I don't want to promise that I'll make them every day. I'll probably, again, do them about every 2 or 3 days. So first, I'm going to start with this. Again, I will include all of these blank pages and all of that I'm using attached to the email when I do send out this email to notify you that this video is up. But what I'm going to do is go ahead and show you these are all of the formulas that are going to be used on the notes that we will be using today. Also, the next thing is I've already gone ahead. If you want to go ahead and start while I'm saying a few things, I've already gone ahead and written in the first part just to save some time because it's hard to that's probably the longest thing I had to write on these notes, and it's hard to write while my hand is in front of it. Okay, so what you can use these lessons for, or these videos. Basically, I know they're a little bit hard to follow. It's hard to follow the tutorials sometimes. As much as I'm going to try to help you guys, the tests are still a little bit harder than what the tutorials give you. I took the mastery test after I did these, and I think there was maybe 1 or 2 questions that I could tell were a little bit iffy for maybe a student who was being introduced for the first time to these formulas. Just to give you a hint, if you are taking the mastery test, one of the questions that I thought was a little bit tricky was just the way it was worded, because it didn't blatantly tell you what to do. It said something about find the volume of the space that was not being used by the shapes. Basically, you have a big shape and you have a small shape. In that big shape, you take the volume of the bigger one, you take the volume of the smaller one, and then you subtract those numbers. So just a hint for that question. And again, there were a few others. Just watch it, be careful, take your time. I'm willing to let you retake mastery tests. You just have to let me know and I'll wipe them out. I will unlock mastery tests when they get locked. Typically, you can just go back through the tutorial and it will unlock them for you. But if you are someone that's gone through them already maybe twice and it's still not unlocked, you can shoot me an email, or at the end of the night, I do try to reset them all for the next day. Also, if you do want to retake a mastery test, I will allow that, but I am probably going to do a cutoff of like no more than 2 retakes because I don't want to get bombarded with emails and people not even trying. So be careful when you ask for a retake. Actually have studied and tried, so you know when you do retake it, it's not that bad. Okay, so in this lesson, this is the objective, and this is explaining volume formula. So this is for this mastery test. In this lesson, you will give an informal argument for the formulas of the circumference of a circle, the area of a circle, and the volumes of a cylinder, pyramid, and cone. So that is what was written at the top, area and circumference of a circle. So I had already started this, and then I had to go back and erase it because I realized when I recorded, there were a few sections that were cut off, which is like this part down here. So I'll make sure to push this up when we get to that one. So then we have area and circumference of a circle. All circles have the same ratio of circumference to diameter. That is the reason that we use diameter in our formula, because of this ratio. This ratio is the mathematical constant pi. So they typically shorthand pi to 3.14. On our graphing calculators, we have the symbol for pi, so you usually don't round it until they tell you to do so. All the questions on here and that I noticed online for this program were shorthanding it to 3.14. Using this ratio, an exact formula was determined for the distance around the circle. So that's what this little image here is, if you can tell that I erased. Basically the distance around the circle, not the area inside of it. So the distance around it, this is called circumference. Okay, here is the formula for it. The circumference of a circle is pi times d. But we also know that the diameter is twice the radius. So if you split that up, then the other formula is 2 pi r. So those are the two formulas that you will typically see. I have it highlighted because it's an important one. The constant also appears in the formula for the area of a circle, which can be derived by dissecting a circle into many parts and arranging the parts to form parallelogram-like shapes. So basically I drew a circle earlier here, and I stated that it was the shaded part inside of it. And they did mention in there that it was parallelogram-like shapes. Basically what they're saying is we could take and we could make some shapes here, and we could kind of find the area of a parallelogram till we fit all of them in. But since this is a curved shape and it has this space here that you would not be able to encompass, that's where we get that 3.14 that comes into play. There might be some sort of video that I share, maybe when we return, where it shows that maybe like in a visual so you understand it a little bit more. But nonetheless, the area of a circle is represented with pi r squared. Okay, so now I'm going to push this up. So this part down here, I've already filled in, but let me erase it so we can fill it in together. Basically what this is saying is, what's another way of writing this formula, but instead of using r, we use the fact that we know that the diameter is 2 times the radius. So to do that, the first thing I'm going to do is I'm going to write down area equals pi r squared. But I'm going to try to replace this r with something. So what I'm going to do is up here, I know that diameter is equal to 2 times r. Well, if I'm trying to solve, if I'm trying to solve for r, all I have to do is get rid of that 2. So I divide both sides by 2. And now I have this, r equals d over 2. So now I can replace my formula. A equals pi, but instead of using r, I'm going to use d over 2, and I'm still going to square it. So that's where we get to here. The next step is you're going to take this and you're going to put it on both of them. When you put it on both of them, d just becomes d squared, so that's what that first one is. But 2 is actually 2 squared. 2 squared is 4, so that's where the 4 comes from. And that's what this reading is about. So I'll read it really quickly, but this was all the math that went with it, and that's all it was. We usually represent the area of a circle in terms of its radius. Using the equation area equals pi r squared, which is what I did there, the diameter of the circle is equal to 2 times the radius. Another way to say that is that the radius is equal to 1/2 of the diameter, which is what I wrote here. Using this fact, we can rewrite the formula to the following form, and then applying the exponent and simplifying the result gives the following equation. So here's the following equation. To kind of clean it up, to show it, this is the equation they're talking about. Okay, so that's what it looks like without those little dotted lines. I'll go ahead and tell you that I will not use this formula. If ever, the only reason you need to use it is if they ever give you like diameter instead of radius, but you can always take the number for the diameter and divide it by 2 and then still use this top one. I would still use this one. That's what I would do. Now, if you can remember this formula and you want to just plug in the diameter, that's okay. Again, for me, I wouldn't do it for the reason that it's just another formula I have to remember, so I wouldn't do it. Okay, so that's it for that page. We only have 2 more pages, so now we're going to go back to the top and we're doing volume formulas. So we've moved on from circles and areas of circles, and we're now moving on to volume formulas. When you use formulas to determine the area of 2-dimensional shapes, the areas are expressed in square units. Okay, so this is important. It's anytime that you're building something, when you take the area of something, you multiply, length times width, times like that, you get area squared. So you'll have like feet squared, inches squared. That is really important right now. Part of the reason why I didn't record these videos before is because they've been like working on my house, putting in flooring and things like that, and it's been really loud, so I haven't been able to get on to actually do this. Well, for that reason, when we had to like do measurements to buy the material and things like that, sometimes we had to abide by certain things. If you were doing something with square units, you divided, for example, if I was converting feet to inches, I wouldn't divide by 12, I would divide by 144, because 12 times 12 is my square unit. So that's really important because that makes a big difference in measurements. So as those who are going to be more involved in like construction and maybe homework, that you know, actual like home decor and things like that, you might be interested in something like that. Okay. So for example, if you need to find the area of a circle whose radius is stated in inches, you write the area in square inches. So typically you'll write it like this. You'll put like the word inches and then you'll put like a square there. So that's usually how we represent it. Okay, plane figures have 2 dimensions, but solid figures have 3 dimensions, which is what we're gonna get to here. When calculating volume, that's for 3 dimensions, the units are cubic units. That is units of length cubed. All that means is you're gonna multiply by 3 things instead of by 2. Okay, for example, the volume of the right cylinder, a cylinder in which the bases are directly over one another. So this is considered a right cylinder because this space and this space are right on top of each other. They're parallel and they haven't shifted in any way. Can be found by multiplying the area of the base. Okay, this is the base, which if you can't recognize from the picture, it's a circle, by the height. So this is why we had to start on the other page with the area of a circle, because if we don't know how to take the area of a circle, we'll be stuck. You're going to find the area of a circle, and then you're going to multiply that by whatever the height is. So I'll put an H here, and I'll put base here, so we know that those are the 2. For a right cylinder, the base is a circle, just stated that. To find the volume of a right cylinder, you're going to take the area of the circular base times the height, so I just stated that as well. Okay, so we're going to push this up. What about a cylinder that has a slant in it? So like if you can tell, this base and this base, they are parallel to each other, but they've shifted a little bit. The volume of a cylinder does not change if you slant the axis of the cylinder, but it keeps the height the same. The volume of an oblique cylinder, this is considered an oblique cylinder, so this is considered a right cylinder, oblique cylinder, is the same as the volume of an upright cylinder with the same base and height. Cones are similar to cylinders as they have a circular base, and we'll see a picture of that in the next page, but instead of having 2 circular bases like the cylinders do, cones taper to a single point at the top. Let's see if we can find the volume of a cone. Okay, and if you have been keeping up with the formulas, basically this is the formula, sorry, before we move on, of a right cylinder. If you actually want to write it out, it is on that other page that I showed you, but we found out from the front that the area of a circle is pi r squared times h. So the actual formula that we would write would be, and I could get this from here, the volume, yes, volume of a cylinder is written this way. Okay, so if you wanted to write that in, you could. Again, it's listed already on that other page, so as long as you have that other page either printed out or somewhere there, you could always go back to it. But that is how we derive it, because we know that the area of the base is circle, that's the area of a circle, and we know the height is going to be h. Okay, so now moving on, because we're going to derive from that fact up here. Given a cone and a cylinder with the equal radii and heights, the volume of the cone is exactly 1/3 the volume of the cylinder. All this is saying is, imagine that this was a cone. Sorry, imagine that this was a cylinder originally. So right there, I kind of drew in a cylinder. So it has the same height as the cylinder. It has the same as one of the bases. It's missing the top base though. So that's all that little statement is saying. The volume of a cone in that case would be, and if you haven't noticed from the list, the number that they use over and over again for the fraction is 1/3. So the volume of a cone would be 1/3 the volume of the cylinder. So if you remember from the previous one, the volume of a cylinder was pi r squared h. So if you can just remember that formula and just put a 1/3 in front of it, you'll have the volume of a cone. And the reason that is because all this extra space here is taken out, and that's why the volume of a cone is only 1/3 of the volume of the cylinder. Okay, now let's compare the volume of a square pyramid. So we're moving on to a pyramid and a cone. So just like this was 1/3 of the cylinder, now we're moving on to a pyramid. A pyramid will be 1/3 of the cone. So as we derive the formulas, that's what we'll get. Similar to the relationship between a cylinder and a cone, the volume of a square pyramid is actually 1/3 of the volume of the cube given the same. Oh, I said that wrong. Sorry. Let me backtrack so I don't have to edit this. I said it was going to be 1/3 of the cone. It's going to be 1/3 of, so if you imagine that this is a cube that you have here. It's a little bit hard to draw it from here. But if you imagine that there's a cube that encompasses this one here, it's 1/3 of the cube. I said cone earlier, so that was wrong. Okay, so now getting to this one. So it's 1/3 of the cube given the same height and base. Okay, so if you don't remember, if you have a square base, it's just, to find the area of a square, it's just length times width, and both sides are the same. So they usually represent it with s times s, which is s squared. So when we get to that spot, that's the same thing as length times width. Okay, so let's do an example. If the pyramid has a square base with side length s and height h, which formula represents the volume of a pyramid? Since the base of a pyramid is a square, the area of the base is, we already talked about that. And before I forget, let me go ahead and highlight the area of a cone. Okay, so if we know that this is the base of the pyramid, now I just need to figure out how I'm going to get the formula from that. Well, the volume of a pyramid is 1/3 the product of the base, area, and the height. So the volume of a pyramid is, put the 1/3 in, and then put this s squared in. It's already got the squared, and don't forget about the height. So there is your formula for the volume of a pyramid. Okay, just imagine those little dotted lines have gone away. Okay, so we're going to push this up just a little bit more, and this is our last part. Okay, key term. Cavaliere's principle is applicable to all three-dimensional shapes, including, so the things we just covered were cones, prisms, and pyramids. Okay, so if you're not sure what they are, cones are pretty simple. I think you can understand that. Pyramids are pretty simple. Prisms are like the cylinders. Basically, prisms will have one base and then another base like right beside it, and then they connect up. So that's what makes it a prism. Cavaliere's principle implies that a tilted cone or pyramid has exactly the same volume as an upright cone or pyramid with the same base and height. So we already talked about this. We said that if it was slanted in any way, it was still going to be the same formula. Doesn't matter if it's slanted, it does not change it at all. Okay, the formulas for the volumes of a cone and pyramid are applicable even if their shape is not upright. So which is what we just stated. What is the relationship between the volume of a rectangular prism and a pyramid with the same base area and height? So let's talk about that. So if we had the volume of a rectangular prism and then a pyramid with the same base area and height. So I'll kind of draw a picture. So rectangular prism would look something like this. So it's basically like a long cube. Okay, so there is your rectangular prism. And then you have a pyramid with the same base as we just did. So I'll do the same base. But remember, pyramids tend to have this apex that they all go to, so it's a little bit hard to see. Draw it a little bit better. And I'm actually going to draw this dotted line to show. Okay, so that's a little bit better. Okay, so what this is saying is, what is their relationship if they have the same base and the same height, but one is a prism and the other one is a pyramid? So we know that the area of this right here, well, it's a little bit off of the page, you can't tell, but we know that the area of this pyramid, as long as it's got the same height and the same base, will be a third of the cube that will be encompassed in there. So for that reason, it will be 1/3 of the volume, and this would be the pyramid, is 1/3 the volume of the prism. So this is just basically stating the same things that we already saw. We saw the number 1/3 over and over again. That's basically what that said. Okay, so we are done with the notes, and the summary is not a question that you have to answer. It's not something that's going to get asked for you on the mastery test. It's just something that in case you need to like state the things that we just went over in Edmentum in your own words, if it's something that you could develop. Okay, so the volume formulas, oops, I got the wrong one. This is not the one that's highlighted. Let me put this one back. Okay, so let me put the ones that we highlighted were these. Okay, so now that we have those done, so again, here are the formulas. These will be attached in the email, and then you'll have a blank one of these to do on your own if you'd like. So again, this is not something you have to do. It's not for a grade. It's something to help you when you take your mastery test. So you have these. If you want to print them out, you can do that. Also, it's going to be a PDF that should allow you to type into it. So you could type these in essentially as you're, as you see me do this tutorial, this video, and you don't have to print them out. You could just have them saved in your PDF that way. But just to reiterate the things that we did. Change pi to 3.14 because that's what they're going to ask you to do in Edmentum. I do think they're a little bit complicated. We didn't really work anything out in this examples, and they do have some they want you to work out. Basically, they just want you to be able to apply these. That's it. So if they give you radius, can you plug it in the right spot, into the right formula? Again, try your best. If you're not sure, let me know. I can try to guide you through one if you need to, but I really need you to be specific on it. And I will say sometimes the questions do change. So if you took a test and you had a really difficult question, it might not show up the next time. Also, just try your best. If you do get locked out or if you want to retake it, let me know and I will try to help you with that. I did try this video sideways instead of up and down. The Algebra 2 one was up and down, and I don't know if that helped or not, but leave me either an email or a comment to tell me if you did find this helpful. And again, I can see the number of views. I can see who has logged on. If this is something where I'm not speaking to anyone in particular and nobody's watching them or taking advantage of it, I don't want to waste my time. I'm trying to help you guys. So if you do think these things will be helpful, do that, use them. I will try to cover again every 2 or 3 days. The next topic, which I think this one is explaining the volume formulas, and I think the next one was using the volume formulas. So again, try your best, do what you can. Don't stress too much. My guidance, my suggestion is try to do about 1 mastery test a day. No more than that. You could essentially try to do a whole bunch and knock them out, but I'm seeing some really low scores because you're probably rushing to try to get some of those done. My suggestion would be to just try to get what you can done. I would say 1 a day would be fine. I don't think that's a lot, and you have other classes you also have to worry about. So take about an hour a day to try to do the tutorial, go through it, take your time, take some notes. And then if you don't want to watch these videos, you don't have to. You could also essentially have the blank notes in front of you the way I did and start filling them out on your own. I would pause the tutorial and fill in a few things. Sometimes I'd have to rewind it to catch a few things. But again, you can do that. Try your best on it. And after I get done with all of the tutorials and mastery things, then I'll move on to the spiral review. Again, that's something that I want to cover when we come back and we do all that. But right now, try to get these Edmentum stuff done, you know, by the 24th, which is when we're supposed to come back. Okay, I will talk to you guys again when I upload something else.